Hello, my name is Bart Brecka, and in this fourth installment of the Beyond Design ACCO Swingline stapler developed in the late 90s, I'm going to make some modifications to this model and add ribs. First off, this part doesn't have a radius, so I'm going to go ahead and put that on. This upper housing needs ribs, so I'm going to go ahead and place a handful of ribs inside of this geometry and pattern them. And a lot of high-end users they don't do what I'm getting ready to show, so I think this will be interesting. So I'm going to go ahead and go into insert just after the shell, and I'm going to sketch a rib. I'm also going to give away a little bit of information on our manufacturing class. It's basically a 2-day plastic part design, 2-day die casting, and 1-day forging. Okay, so this rib should be 70% of the material thickness, so I'm going to go ahead and create a parameter and drive that number using a relation. But before I do that, I'm going to go ahead and just extrude this through next, and if you'll notice, I've overbuilt the geometry, and through next just works. And when I solidify the remove that last solidify, it cuts it just as one might expect. So I'm going to go ahead and pattern that with respect to that number, negative 1.5 or 6 there. That's fine, and I'll see if I can get 5 to pattern across there. And in the same respect, whatever I do to this solidify just cuts it off. Okay, so now I'm going to create a parameter. First, let's create a relation. I'm going to create a parameter first. Let's do a THK for the material thickness, and we'll set that to 0.11. Okay, and I'm going to hit OK here, and then I'm going to tie in this 0.13 shell thickness as a parameter, and I'm going to call it THK. I'm going to tie it to the parameter. Basically, I'm just adding a relation on the fly. Hit Control G, visual confirmation that it added because it required the update. And now I'm going to right click through here, and I'm going to set this geometry to THK times 0.7 to maintain the 70% rule. One of a couple hundred tricks for plastic part designers and die-cast people alike. Well, if you had this part in front of you, you might point out that that's not exactly what the ribs do. They don't get sawed off right here at that solidify like that. So what I'm going to do is I'm going to delete the pattern. I'll leave that one rib there, but I'm going to let's just delete it. Delete the relations. So now what I'm going to do is I'm going to put the rib in and have it follow a curve, and like anything, the weakest link is probably where it's going to fail. So I'm going to go ahead and create an intersect surface between the datum plane and this geometry. I say weakest link because I don't want to have to find out exactly where this edge is and use edge here, 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 here. Look, there's another one. That's a lot of extra geometry. I could in sketcher mode, project a curve onto this edge, and that's just a lot of extra geometry. This geometry here goes back to the original, curve. It's basically 3 entities. It's a little bit more simplistic, which is what keeps our models more extraordinarily robust. Is because it's simple. Now I'm going to use an offset. A lot of people would never think to use an offset on a curve. They only use it on a surface. So what I'm doing is I'm creating an offset on the curve, and I'm offsetting it in a direction in a plane. I'll just set it at 0.2 or something like that. And then I'm going to hide the original curve. And let's place a point along the curve. I'm going to right click once to get the entire curve, and I'm going to reference a datum plane. I pretty much do this on every rib, and I tell you, you can't do this stuff in you can't do what I'm getting ready to do in SolidWorks. I guess you just get to model all the ribs as individual features, and I'm going to pattern them. So I'm going to build a datum plane now through, and I'm holding the control key down so I can make the datum relative to this front plane, parallel to the plane. You can see it's set to parallel. Now I'm going to go ahead and create a sketch just like I did before. I'm going to go ahead and bring it off a little bit to the side. I'm going to draw a center line down the center. I'm going to try to maximize my sketcher constraints. Just made that on the fly, the midpoint. If you rotate it off in just a little bit of an edge, it's easier to grab the point. Now I'm going to go ahead and tie this now in sketcher mode to the parameter I created called thick. So I'm going to type it in. And because it's below the geometry, it's going to basically allow me to solidify in a just going to create a do next constraint here. Now let's pattern this whole lot of geometry. So I'm going to go ahead and create a group out of that and pattern the whole lot with respect to that number, negative 1.7. I think I could probably get 5 or so in there. Little click. Very different way to pattern, and you can't do that in SolidWorks. Alright, so one last thing I might want to try to do is manage how wide the part grows. There's always, when companies like Nike have to, the engineers have to present their concept and their engineering ideas to a group of people. And there's always one person in your office that's trying to trip you up and make you look dumb in a big meeting. So what I'm going to do is try to set this model up so that I can just grow the entire geometry, and it's not going to fail. So that one guy I'm anticipating is going to say, can't you make it any wider? So what I'm going to do is I'm just going to come up here to this first geometry and make it 2 inches, and there's going to be a bunch of stuff that fails. Okay? A lot of things fail because I didn't have that intention. So what I'm going to do is I'm going to create a parameter in my skeleton model called width. And my value is I'm going to set it to 2 because my whole entire product's mirrored. So basically what I'm going to do is I'm going to come into each one of these features and tie this to width. This will be width divided by 2 because it's half. Hit Control G. Let's set this one to width divided by 2. Control G. Let's set this to width divided by 2. Okay, and there's probably a handful of others. Each one of these needs to have a width dimension. This one's the entire distance, so I'm just going to call that width. Do that 3 times. In my plastic part design class, I try to share all the mistakes that I've made in a plastic part design model while at Motorola or various companies, and technique and workflow that will not allow you to make the same mistake. And that's kind of why this class is so valuable. It sets you up to succeed, not sets you up to fail. So let's exercise our geometry. I'm going to come into my parameter, and I'm going to change 2 to 3, and now let's see how it works. If something fails, we got to go fix that. I forgot one. So let's double click on that one and set that distance to width divided by 2. Okay, exercising the part. It's a really healthy idea to do. You want to do that before your manager gets there, because he's going to ask for 20 changes. Marketing's going to ask for 6 or 7. And now I think we've got a model that's on the robust side. Let's set this now to something ridiculous like 5. That can't work. Hit regenerate. Okay, and sure enough it works. Let's go ahead and see if we can update in the assembly. Okay, so with design engine style of training, you can design a product and allow it to change in ridiculous ways that you couldn't before by simply taking strategic advantage of parent-child constraints, parameters, and relations, and dimensioning your sketches intelligently. This is my last installment for the stapler, the ACCO stapler exercises and demos. Please consider coming to Design Engine in the future. Thank you.